This is an audio-visual presentation on modulo arithmetic. When a number is divided by another number and we are only interested in the remainder left, then we are doing modulo arithmetic. I repeat, when a number is divided by another number and we are only interested in the remainder left, then we are doing modulo arithmetic. Example, 7 mod 6 is equal to 1. Why is the answer equal to 1? This is because we have only one group of 6 in 7 and the remainder is 1. Since we are only interested in the remainder, the answer is 1. 40 mod 7 is equal to 5. This is because we have 5 group of 7 in 40 and the remainder is 5. 17 mod 3 is equal to 2. This is because we have 5 group of 3 in 17. That is, we have 5 groups of 3 in 17 and the remainder equals 2. 36 mod 6 is equal to 0. Why is it equal to 0? This is because we have 6 groups of 6 in 36 and the remainder is equal to 0. So now I go over this again. 7 mod 6 is equal to 1. This is because we have only one group of 6 in 7 and the remainder equals 1. 40 mod 7 is equal to 5. This is because we have 5 groups of 7 in 40 and that 5 groups of 7 will give us 35, and so we can see that the remainder is 5. That is why 40 mod 7 is equal to 5. 17 mod 3 is equal to 2. This is because we have 5 groups of 3 in 17 and the 5 groups of 3 in 17 will be 15. So we can see that the remainder is 2. That is why 17 mod 3 is equal to 2. 36 mod 6 is equal to 0. This is because we have 6 groups of 6 in 36 and 6 groups of 6 will give us 36, and so the remainder is equal to 0. Now, modulo of a negative number. In general, the modulus of a negative number is obtained by adding the modulus to the number repeatedly, and the first positive number we obtain becomes our result. In general, the modulus of a negative number is obtained by adding the modulus to the number repeatedly, and the first positive number we obtain becomes our result. Now, example, I minus 19 mod 12. Because the number is negative, that is minus 19, and we are working in mod 12, we keep on adding the modulo to the minus 19, that is the number, till we get the first positive number, and the first positive number becomes our result. So minus 19 mod 12 will be equal to minus 19 plus 12, and minus 19 plus 12 is equal to minus 7. Because it's still a negative number, we have to continue the addition, so plus 12. Now minus 7 plus 12 is equal to 5. This is our first positive number, so that is the answer. This means that minus 19 mod 12 is equal to 5. Now I minus 12 mod 7. Because the number is negative and we are working in mod 7, we have to add 7 to the number minus 12 until we get the first positive answer. So minus 12 mod 7 is equal to minus 12 plus 7. And minus 12 plus 7 is equal to minus 5. Because the answer is still negative, we continue to add the modulo, so plus 7 again. And minus 5 plus 7 is equal to 2. So 2 is our first positive answer, and therefore minus 12 mod 7 is equal to 2. I minus 5 mod 9. Because the number is negative, that is negative 5, and we are working in mod 9, we add 9 to the number minus 5 till we get the first positive answer. So minus 5 mod 9 is equal to minus 5 plus 9, and the answer is 4, and 4 is the positive answer. So that is the first positive answer, and therefore minus 5 mod 9 is equal to 4. So with the modulo of a negative number, we add the modulo to the number till we get the first positive answer, and that becomes the result. That is how we find the modulo of a negative number. Now we look at addition and multiplication of modulo. Example, 3 plus 5 mod 7. Now 3 plus 5 is equal to 8. So 3 plus 5 mod 7 is equal to 8 mod 7, and the answer is 1. Take note that with modulo arithmetic, we are only interested in the remainder. So 8 mod 7 is equal to 1. Why is it 1? We have only one group of 7 in 8, and the remainder is 1. 5 plus 9 mod 6. 5 plus 9 is equal to 14, and 14 mod 6 is equal to 2. Why is it equal to 2? This is because we have two groups of 6 in 14, and the remainder is 2. Because the two groups of 6 will give us 12, and so we can see that the remainder is 2. 5 times 7 mod 8. When we multiply 5 by 7, the answer is 35. This means that 5 times 7 mod 8 is equal to 35 mod 8. Now 35 in mod 8 is equal to 3. 35 mod 8 is equal to 3. This is because we have 4 groups of 8 in 35, and the 4 groups of 8 will give us 32. So we can see that the remainder is 3. Now 11 times 6 mod 3. 11 times 6 equals 66. So 66 mod 3 is equal to 0. Why is it equal to 0? Because we have 22 groups of 3 in 66. And that 22 groups of 3 will also give us 66. And therefore the remainder is equal to 0. Now let's look at tables of modulo arithmetic. This is an addition table for modulo 5. And so with modulo 5, 4 is our last digit. So on the table we have 0, 1, 2, 3, 4. Then we also have 0, 1, 2, 3, 4. That is how we construct the addition table for modulo 5. So now let's start. 0 plus 0 equals 0. Because it's not up to the modulo, we write the number. If the answer is not up to the modulo, write the number. So 0 plus 0 equals 0. 0 plus 1 equals 1. 0 plus 2 equals 2. 0 plus 3 equals 3. And 3 in mod 5 equals 3. Because it's not up to the number. Now 0 plus 4 equals 4. 4 in mod 5 is 4 because it's not up to the modulo. Now 1 plus 0 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 1 plus 3 equals 4. And 1 plus 4 equals 5. Now 5 in mod 5 equals 0. Why? Because we have 5, only one group of 5 in 5. And the remainder is 0. 2 plus 0 is equal to 2. 2 plus 1 equals 3. 2 plus 2 equals 4. 2 plus 3 equals 5. And 5 in mod 5 equals 0 because we have only one group of 5 in 5 and the remainder is 0. Now 2 plus 4 equals 6. And 6 in mod 5 is equal to 1 because we have only one group of 5 in 6 and the remainder is 1. Now we continue. 3 plus 0 equals 3. And 3 in mod 5 is 3 because it's not up to the modulo. Now 3 plus 1 equals 4. 3 plus 2 is equal to 0. This is because 3 plus 2 is giving us 5. And 5 in mod 5 is 0. This is because we have only one group of 5 in 5 and the remainder is 0. And since we are only interested in the remainder, we write the remainder. Now 3 plus 3 is equal to 6. And 6 in mod 5 is equal to 1. 6 in mod 5 is equal to 1. because we have only one group of 5 in 6 and the remainder is 1. We are only interested in the remainder, so we write the remainder 1. That means that 3 plus 3 in mode 5 equals 1. Now 3 plus 4 is equal to 7, and 7 in mode 5 is equal to 2. Why? Because we have only one group of 5 in 7 and the remainder is 2. Now we continue. 4 plus 0 equals 4. We write 4 because it's not up to the modulo. Now 4 plus 1 equals 5, and 5 in modulo 5 equals 0 because we have only one group of 5 in 5 and the remainder is 0. 4 plus 2 equals 6, and 6 in mode 1 is equal to 1 because we have only one group of 5 in 6 and the remainder is 1. 4 plus 3 equals 7, and 7 in mode 2. 7 in mode 5 is equal to 2. I repeat, 4 plus 3 equals 7, and 7 in mode 5 is equal to 2. Why is it 2? This is because we have only one group of 5 in 7 and the remainder is 2. Since we are only interested in the remainder, we write only the remainder, that is 2. Now we continue. 4 plus 4 is equal to 8, and 8 in mode 5 is equal to 3. This is because we have only one group of 5 in 8 and the remainder is 3. This is how we construct tables of modulo arithmetic, and this is an example of an addition table for modulo 5. This is the end of our presentation on modulo arithmetic.